Greetings and welcome to the CCO Foundation Managing Soil and Irrigation for Drought webinar. We wanted to acknowledge that today's webinar is supported through a grant from the USDA Risk Management Agency. Any opinions, findings, conclusions, or recommendations expressed in this webinar are those of the authors and do not necessarily reflect the view of the U.S. Department of Agriculture. If you're having difficulties connecting to the webinar, if you can't hear or can't see, please call our office for support at 831-423-2263. Press 0 for the operator and someone will help you connect to the webinar. My name is Megan Donovan. I will be your host today. I am a program specialist at the CCOF Foundation. The CCOF Foundation advances organic agriculture for a healthy world through education and hardship grants, technical assistance, and consumer education. We are pleased to have both Steve Amador from Modesto Junior College and Rex Dufour from the National Center for Appropriate Technology with us today. I'll introduce each speaker in more depth prior to the presentation. Before we get started with the main presentation, I wanted to let you know how you can participate in today's web event. We're looking at an example of the GoToWebinar attendee interface, which is made up of two parts. The viewer window on the left, which allows you to see everything the presenter will share on the screen, and the control panel on the right. Within that control panel is how you can participate in today's event, so let's go ahead and take a look at that. By clicking the orange arrow, you can open and close the control panel. From the View menu, you can also set the control panel not to auto-hide when inactive if you prefer to always keep it open. The audio pane provides audio information. By default, you have joined the webinar via mic and speakers. If you prefer, you can join the audio via telephone by selecting phone call, and the dial-in information will be displayed. During the presentation, you can send questions to our webinar staff through the questions pane. Simply type in your question and click send. Throughout the webinar, we will stop from time to time for questions and answers, and we'll get to as many questions as possible. As a final reminder, today's webinar is being recorded, and everyone will receive an email with the link to view today's recording, along with a PDF of the PowerPoint slides. Today, we also have a copy of the PDF of the PowerPoint slides available for download through GoToWebinar. Click on the blue file name in the handout of the Handouts pane. A PDF of the slide will open in your internet browser. You can view them in your browser or download them onto your computer. To expand or collapse the Handouts and Questions pane, click on the triangle next to the name of the pane. For example, if you can't see the box on the Questions pane, click on the triangle and it will expand the pane to show the box. So we wanted to encourage you to test out the Questions pane. Write in, let us know where you're calling in from today and what crops you grow. And we'll loop back around to that information a little later in the presentation. We also wanted to say that we have a nice crowd in the audience today, and we're going to try to get to as many questions as possible. But if we don't get to your specific question, please follow up with us after the webinar. And also just to note, we're going to be talking about some regulations around irrigation today that are specific to California. But other than that, most of the content is, broadly based for folks outside of California as well. So with that, I'd like to introduce our first speaker. Steve Amador currently directs the irrigation program at Modesto Junior College and teaches a number of courses for students pursuing degrees in irrigation technology. After graduating from Cal Poly San Luis Obispo in 1986, Steve spent 10 years working in industry prior to entering the teaching profession. He is now in his 16th year at Modesto Junior College. Steve believes that the success of California agriculture relies on sustainable use of its natural resources and, most importantly, its water. So Steve, thank you very much for joining us this afternoon, and I will hand the presentation over to you.
Okay, thank you very much, Megan, and hello, everyone. In this presentation, I'd like to discuss a little bit about how we can use our water effectively. In the state of California, we're looking at the Sustainable Groundwater Management Act coming down the line. We're looking at the Bay Delta model, Bay Delta plan, and use of our surface water, and and I think those are California regulations, but nationwide or worldwide, I think we're looking at using water wisely to sustain agriculture. Do I have control of the slide? Oh, there we go. And so I think the major goal we have is saving water. So we save money. We maximize our use of our energy. We maximize use of our natural resources, and we can just use our water wisely. And so where do we begin? So today I'd like to talk first to determine how we determine water needs of the plant. Analyze the soil and the water holding capacity of our ground. Evaluate irrigation systems for efficiency and schedule irrigation times and application rates. I tell students that, I ask students at the beginning of every school year, those students that families farm or they're growers or children of growers, and I ask them, how often you irrigate? What do you grow and how often you irrigate? And I get answers, a week. I get answers 10 days, 21 days, whatever the case may be. And then I get answers, and then I ask, how long do you irrigate? And 24 hours, 48 hours, whatever the case may be. And then I ask why. Why are you irrigating every 10 days and why for 24 hours? And the answer often is, well, that's because my grandparents did that or my father did that. They're successful. That's what we continue to do. And they were successful and they are successful, but I don't think we can leave it up to that any longer. I think we can't leave it up to past or older practices. Let's determine what the water that the plant needs. Evapotranspiration rate for a plant takes into all the water uses of that plant. That's measured in inches of water. In California, we use the CIMA site, the California Irrigation Management Information System. A very, very useful site, very user-friendly site, and we can log on and we can create an account, and then we have a lot of information available to us. The link is there. As you see below, there's at the bottom of the page, there's a report I ran. The report, we'll zoom in on the report. The report gives us a great deal of information. It gives us the evapotranspiration rate. It gives us air temperature, dew point, wind speed, all the above. You'll notice that this report is taken from weather station number 71 to closest to our Modesto Junior College School farm. Actually, it's about 8 or 10 miles away, but nonetheless, it's the one that we look to for information. I ran a report from a random week in the middle of July, and July being the biggest water use. And what's really important in all this information is I'll zoom in, is that evapotranspiration rate for grass. ETO is a reference that CIMAS uses for grass. And so on the 14th, the grass reference used 0.28 inches of water. On the 15th, we used 0.3, 16th, 0.3. At the end of the week, we add them all up and we use 1.8 inches of water for that grass reference. If we take a look, the picture in the lower right is some data that comes from Washington State University's Extension Service. Earlier today, I looked up, I saw there were some attendees from Texas, and Texas A&M Extension Service has a very nice website. In fact, I kind of like the Washington and Texas sites better than our own SIMA site here in California. But nonetheless, over here on the left, on the upper left, we have some data of evapotranspiration rates for a weather station on the MJC campus. And so that allows us to get more, and you know, it's expensive, but I should clarify that. I believe we paid about $2,400 for the weather station, and our service, our fees are somewhere in the $800 range a year to have access to this data. But that gives us data on site, and so it's a little more, we feel it's a little more accurate. We feel a little more pertinent to our situation. But nonetheless, we got an ET rate, or evapotranspiration rate, for grass. And so now what we need to do is we need to convert it to the crop we're growing. Our school farm, we have about 40 acres of almonds, and we're pretty much surrounded by almonds here. So the example I'm going to use today is for almonds. It's really easy, though, to switch over to whatever crop it is that you're using. And so the evapotranspiration rate was for grass. We're gonna convert it over to an evapotranspiration rate for our crop by using what's called a crop coefficient. And so this data in the chart comes from the California Almond Board, and I believe that it originally came from UC Davis. And a lot of crop associations have crop coefficient data. UC Davis has a lot of California crop, and I'm sure the Extension Service in other states has a lot of crop coefficient data. So in our example, we're growing almonds, and I'm gonna use the coefficient in July, the most recent, the Goldhammer number of 1.15. And so what that coefficient is telling me is that almonds use 1.15 times the water that the grass reference does. And so we're going to use that actually as a multiplier. And so if we go back to the original chart we had, and on the 14th, we had 0.28 inches of water, and we multiply it by that crop coefficient, almonds are going to use 0.32 inches of water on that 14th, 0.35 on the 15th, and so forth. So we could actually run an irrigation system and apply that 0.32 inches of water and meet the needs of that plant. Sometimes because of cultural practices, you know, we don't want to irrigate every day, or system requirements, we don't want to irrigate every day. So we can stretch it out, and if you look at the bottom, if you add those up, we use 2.18 inches, almonds use 2.18 inches by the end of the week. And so at the end of the week, we could apply that much water. But on the other hand, let's take a look. This is the water the plant needs. Let's take a look at what the soil holds. And so we can go to some general data, and sandy loam at field capacity is 2 inches per foot of water, loam 2.7, and so forth. We can use some of this general data, or we can go back to the USDA Soil Survey, with the link is right there. And the USDA Soil Survey is very user-friendly, and you can zoom in on the property that you farm and tell you specific soil data and the physical properties of that soil and so forth. Really handy is also a soil web app. If you just go to Apple Store or Play Store, whatever you use on your phone, you look up soil web app, and it uses GPS data, and it will tell you the actual physical properties and the soil type of the soil you're standing on. So in one field, you can get soil data, move to another field, get soil data from that field. Very handy, free of charge also. But let's go back to the chart. So We're going to continue with our almond example. At field capacity, when the soil is full of water, it holds 2 inches per foot. At permanent wilting point is the point when that plant can no longer pull the water off the soil particles. They are held too tightly, and that plant will start to wilt. And so the distance between those two, the 2 inches when it's full, the 0.8 inches when it's permanent wilting point, is 1.2 inches of available water. And that water is available to the plant. I always like to tell younger students that soil is kind of like a bank account. And so what happens is we put money in there, or in the case of soil, we put water in there. And then we use that money in the bank account, and there's got to be a day when we fill that bank account back up. And we don't want to use it too low, or we don't want to stress plants by going all the way to permanent wilting point. And so again, UC Davis, the California Almond Board, and crop associations, they come up with what's called a maximum allowable depletion. And so of the 4.8 inches in the root zone, I'll take a step back. And so if we go to the other slide and we see available water was 1.2 inches per foot, and you multiply that times 4 feet of effective root depth in almonds, it's 4.8 inches of available water. And with almonds, the maximum allowable depletion is around 50%. And so we use half of that 4.8 inches. Some plants that are a little more drought tolerant, we can dry out that soil a little more. Grapes is a good example. I believe grapes management allowable depletion is somewhere 60-65%. Some fleshy vegetables, the maximum allowable depletion is a little bit less, around 40%. But it's somewhere between 40 and 60%. And so maximum allowable depletion, hangs right in that. We use about half of that water. And with the almonds, we're using exactly half of that water, 50%. So we have 2.4 inches readily available water in the root zone. If we go back to the crop water usage, and it's 3.32 on the 14th and so forth, and we average those out, it comes out to, in July, almonds are using about 0.31 inches per day. If the soil holds 2.4 inches, we do a little bit of division, and we come up with, we have 7.4 days, or 7 days between irrigations in this type of soil. Again, this is a sandy loam situation. Heavier soils hold more water, and we can go a little longer between irrigations. Also, July is the peak water use month. August is really close, June a little bit less, May a little less than that, and so we can stretch the days between irrigation out in those months that use a little bit less water. And so at the end of 7 days, our soil moisture deficit, or we've used that 2.2 inches of water out of the soil. So our job after 7 days is to irrigate and put that 2.2 inches back in there and bring it back up to field capacity. Don't want to put any more in there. Maybe I should take that back just a second. We want to put 2.2 inches in there. The only issue with that is the water that we apply with an irrigation system is never 100% beneficial. It is never 100% uniform. And so we need to take a look now at our irrigation system and what our uniformity is. And so if we apply 2.2 inches, some parts of the field may not get enough. I see it all the time. If you drive, I drive to work and I see we grow a lot of silage corn in our area, and you always see spots of corn that are near the road or in the corner of the field where in a high spot, and they never seem to get enough water, and the corn doesn't do very well in that area. Well, that's exactly what we're talking about with distribution uniformity. So what happens is some of those parts of the field, they don't get everything that they need. And so the picture on the left with the application depth there, that's a perfect situation. The picture on the left is what we have sometimes, where some parts of the field, the application depth is deeper than other parts of the field, and not everything's really getting the water that it needs. And so if you take a look, and what happens with poor DUs is you see the dotted line in the bottom picture, all the roots got what they needed, but on the other hand, to get order for that to happen, we had to overwater some other parts of the field. So uniformity plays a big part in how much water we're using, how much water is used effectively, and how much water is pushed past the root zone. And so let's take a look at DU, or potential uniformity. This is put out by the ITRC at Cal Poly, the Irrigation Training Research Center, and they've done some research, and they're saying that we'll use permanent under tree sprinklers. They say the potential is 95% efficient, or 95% uniform, I should say. And so what happens is, in a system that is well designed, well maintained, then we should be around 95%. Linear move 93, sloping furrows 90%, orchard drip 92%. I did an evaluation with a group of students last year, and a brand new system in Houston on some almonds in Houston, California, and we found it to be 97% uniform in a double line drip. And so I think that's a good place to start is do some testing, figure out where we're at. One thing I'd like to point out is down toward the bottom of those, you see border strip or flood irrigation is 85%, and level furrows are 85%, and sloping furrows 90%. Those are surface irrigation methods that really, in my opinion, have a bad rap, and I think they have a bad rap because we don't always use them to the best of our ability. But flood irrigation, furrow irrigation can be pretty darn efficient if done right. Often, maybe not done right. And so let's measure our own uniformity. 3 times a year, I like to go out and I like to measure at the beginning of the year, I like to measure at the middle of the year, and I like to measure at the end. And I like to keep records and see where my system lies. When I do those tests, I like to do 3 tests in the field. I like to do one up by the water supply. If you look at the picture to the right with the red circles, I do one by the water inlet to the field. I do one that's kind of out in the middle of the field, and I like to do one out in the back corner because things change, pressures change throughout the field, and so forth. In the top left picture, that's an evaluation we did on some grapes, and we put buckets under the emitters, we catch water, and then we measure that water, and we see how uniform they are. In the bottom is a orchard sprinkler situation, and we put water in the catch water in the buckets, and we measure them. After we measure them, very importantly, in the drip, the system has to be running before you start, and also the buckets must be under the emitter the exact same amount of time for each bucket to get accurate numbers. But once we have a representative sample enough to measure, we use plastic graduated cylinders, and we measure the amount of water that the buckets collect. We then take all that data and we put those numbers in order. So I have the bucket with the most water, 175 milliliters, and the bucket with the least water, 68 milliliters. I put them all in a row. We have a 24 bucket sample. Also, I measured these in milliliters. It really doesn't matter what you measure in. It's really pretty simple. You just measure, you can measure ounces, you can measure any volumetric measurement as long as it's all the same. Another thing, I think Ewing Irrigation and Cal Poly ITRC, they sell cups that have graduated cylinders in them, and you can buy a set of cups, I think, for $50 or $100. And but to tell you the truth, it really doesn't need to be that fancy. You just need a cup or something to catch water. You need to be able to measure that water accurately, and that's it. And so when I put all those numbers in a row, I take in 24 samples, the lowest quarter of the values is the bottom 6. I take the average. The average is 78 milliliters. Then I take the average of all 24. After I take the average of all 24, it's 111 milliliters. I divide the lowest quarter by the average of all, multiply by 100, and I come up with 70%. So the DU of my field is 70%. And so I think that's good in that that gives me some data at the beginning of the season. And let's say I start the season and I'm 70%. Well, that leaves us room for improvement, of course. But then in the middle of the season, if I'm dropping off, then I can make some changes and get it back up to our original numbers. Some ways we can maintain good uniformity, and I cannot overstress this. Keep the system the way it was designed. I did an under tree orchard in Houston, California, a walnut orchard, and the distribution uniformity was 40%. After we did it, we started looking around and we found that in the field there were 7 different brands of sprinklers they were using with 7 different nozzle sizes. And so what had happened is the system was designed well, the system was working well, a sprinkler broke, and it was replaced with just something random. And then over the years, the uniformity dropped off drastically because now we've changed it from the way the designers wanted it to be. Keep them the same. Clean your filters, check and replace the sand if you need it, inspect screen filters, flush your lines. Those of you with drip lines, I like to flush them every couple weeks. If I flush them after 2 weeks and I still get a lot of crud out of them, then maybe I should do it every week. Or if I flush them every 2 weeks and it seems to be pretty clear, maybe I can stretch that out to 3 or 4 weeks. But nonetheless, they need to be flushed pretty regularly. Check pressure regulating devices, make sure everything's working properly. Use flow meters and pressure gauge to record data. I tell students to start the pump, start the system, record flow through the flow meter, write it down, and write down the pressure at the gauge. And so if I irrigate today and I have 40 pounds of pressure and 500 gallons a minute, and I irrigate next week and I have 20 pounds of pressure and 600 gallons a minute, then there's something I need to go look at. But if we don't keep those records and we don't take a look at them, I'm not sure how we can make wise decisions. Check for leaks and repairs as needed. I know I've talked to growers that drip systems are leaking all over, and they say, well, what's the difference? It's watering anyway, but it's really not putting it where it needs to be. Surface irrigation methods, flood, grade, level property before planting, and that'll always help your uniformity. Let's go back to our uniformity, our ALMA example. So our soil moisture deficit, the amount of water we need to bring it back up to field capacity is 2.2 inches. We just determine that our system DU is 70%. We do some math and it comes out to 3.1 inches. So what we need to do is we need to apply 3.1 inches of water in order that every spot of the field gets 2.2 inches. So we're going to have some spots that get a little extra water. So we know that we need to apply a gross of 3.1 inches. I have a pump that puts out 1,000 gallons a minute, and I have 20 acres. I do a little bit of math. I take the inches to apply, which is 3.1. I take the area irrigated in square feet, which is 20 acres times 43,560 square feet per acre. I divide that by 96.3, which is a constant, and then multiply it by gallons per minute. And in this case, if you see the math, it comes out that I need to run this system for 28 hours in order to apply 3.1 inches. I tell students, this is my personal belief, that you cannot be effective irrigating without a calculator. If we don't know exactly what we're putting out there, and we're just putting it out there and making visual inspections and basing our irrigation timing off of that, I think we're cutting ourselves short. This is kind of a startling fact here. So my current DU was 70%, and so if we average 0.31 inches of water a day for 31 days, and we have a DU of 70%, that means we applied 13.7 inches of water, roughly almost 14 inches of water in the month of July. If I make improvements in the field, and I get that DU up to 95%, or I replace my irrigation system and I get that up to 95%, then we take that same math and we 0.31 times 31 days divided by a DU of 90. Those plants are getting the same amount of water, 10 inches of water, but they're getting the same amount in the root zone. So we're saving 4 inches of water in the month of July, another 4 probably in August, probably 3 in June. And so now, in May, another 2 or 3 in May, now you're saving an acre foot of water a year. That's 20, in this case, 20 acres, that's 20 acres feet of water. And depending on the cost of your water, that's pretty darn significant. On the other hand, if your water is so cheap that maybe that's not significant, then I'm not sure that, this is my personal belief, that agriculture needs to be good stewards of the land and use water wisely. And as you know, regulation comes down, and it's not agriculture's voice that gets heard. And in California, it's San Francisco and Los Angeles voice that gets heard. And I think it gives us much more fight in the discussion if we can say, you know what, we're doing everything we can as agriculturists. Are there any questions?
Great, thank you, Steve. That was a really comprehensive overview, and thanks for all of the examples as well. So if you have questions for Steve, please go ahead and write those in. And also, we'll start off by looping back around about who we have online, and we have some folks from Lake County, California, and Ojai and Tolmeca, and also someone listening in from Nebraska. And then people are growing olives, hops, avocados, coffee, and winter squash. So one question that did come in is, you kind of showed those charts from different places that showed water use. If you're growing sort of less popular crops, where are good places to get that information from?
And so you're referring to probably the crop coefficient, because evapotranspiration rates for the reference grass is the same across each state. Mm-hmm. Crops that maybe are not as common, I think there's a lot of information on grower associations, and I think almost every crop has a grower association. If it's really something obscure, and maybe find a crop that's similar. And another thing I tell all my students is that irrigation's kind of like a big toolbox, and so evapotranspiration rates in DU are just a couple tools in the toolbox. And in addition to those, we don't have time to discuss today, but some of those other tools are maybe moisture devices, a tensiometer or a capacitance probe telling moisture. Maybe doing some plant-based sensing with infrared or NDVI photography, but so it's like the whole big picture. And so I think we pick something, we look at the moisture probes, and we see how much water is left in the soil, and we do some comparisons. And if it appears that we're drying the soil out too much, then maybe we need to increase that crop coefficient a little bit. But I do think that almost all crops are with an association, or there is some data online for almost everything.
Great, thanks.
That help out?
Yeah, that was very helpful. Okay. And then we have another question. You gave your example on sandy loam. What are best management practices for heavier soils?
Yeah, heavier soils are just going to hold more water. And so the duration between irrigation days is, instead of irrigating every 7 days, maybe we irrigate every 14. Real common in our area, we're a sandy loam. We find a lot of people around here irrigate about every 10 days. I live just south of here in a town in Hilmar, and Hilmar is sand, very, very sandy, and you see them irrigate more often, every 7 days. And then if you go to the west side of the valley, Patterson, Newman, they're stretching those days out to 14 to 20 days because that ground's so heavy. The thing with heavy soils is there's a cultural issue here as well, because you really can't irrigate, every day, let's say, or irrigate. If you irrigate too often, that's hard to get in the field to do anything. And so it just holds a little bit more water, so you can just stretch those days out.
Great, thank you very much. So I think we're gonna wrap questions up for now and move on to our next presenter. But if you think of any other questions for Steve during the second half of the presentation, please feel free to write them in, and we'll have a second question and answer session after our second presenter. So Steve, thanks again. And we'll have a little more time to chat after Rex's presentation. So now I'd like to introduce our second presenter. Rex Dufour serves as the California Regional Director for the National Center for Appropriate Technology, also known as NCAT. Rex's work focus and background is in teaching and learning about ecological pest management and ecologically based soil management. His work experience includes managing sustainable development projects in Thailand and Laos. Rex is registered as a technical service provider with the USDA Natural Resources Conservation Service in California and Nevada. So Rex, thanks so much for joining us this afternoon, and we look forward to your presentation.
Okay. Can you hear me okay?
Yes, you're loud and clear.
Okay. Very good. So I'd like to thank RMA for supporting this work, and also thank Steve for an excellent presentation. Thanks. I'm going to be switching gears and going to be talking to you about soils and soil management, and basically investing in your soils as you would invest in, say, new farm equipment or maintaining buildings or training up some of your farm staff, and talking about what does that look like. And it's not just throwing down some NPK chemical fertilizers. We need to do something different than that. And so, and what Steve was talking about is critically important, particularly in California. We're facing a lot of issues related to water, and as Mark Twain said, whiskey's for drinking, water's for fighting over. And we're looking to, I think that's where we're heading a little bit. But the irrigation volumes need monitoring. The irrigation systems, whether low tech or high tech, furrow irrigation systems, or if you're using some drip or micro sprinklers. Subsurface drip is becoming more and more popular in California. Monitoring the soil moisture is very critical, and then monitoring the evapotranspiration, as Steve outlined. That's really important in order that we use the water most effectively. But one thing that's often forgotten in our kind of focus on irrigation technology is, what about the soil? The soil is where the water meets the planet, or where the rubber meets the road, if you like that analogy. And if we're forgetting about soil health and how that influences the ability of soils to absorb and store water, I think we're missing a big efficiency regulator. And if you're thinking about, you know, most folks have pretty expensive irrigation infrastructure, and if you're not paying attention to soil quality, it's like putting a $100 saddle on a $10 horse. It's simply not as effective as it could be. So that's what I'm going to be talking about. How to make your soil the most effective receiver and storer of water. And keep in mind that right now in the US, we're working with pretty degraded soils. This study, it estimates that about 3/4 of the soils in North America, they're degraded. And going into that study, I've read that study, mostly that degradation is due to lack of organic matter, which results in compaction problems, decreased ability of the soil to absorb water, and to store water as well. And in the West, salinity is also a problem. And I would note that most of the civilizations based on irrigated arid land agriculture are extinct. We're the only civilization that still doing that. So, and hopefully we can continue to do that, but some other things to keep in mind. As Steve had mentioned, something called the Sustainable Groundwater Management Act. That's a California state regulation. Groundwater withdrawals are likely to be restricted, and some folks rely exclusively on groundwater withdrawals for their irrigation. In California, we have a lot of surface water infrastructure, the State Water Project, the Federal Water Project, but the SIGMA, as it's called, is an effort by the state to kind of maintain water tables at some kind of sustainable level. And so in the future, groundwater withdrawals will likely be more strictly regulated than they are now. The idea is that we're going to be working with, if we manage our soils well, that will allow those soils to more effectively absorb, infiltrate, and store water, and then and also nutrients. And storing water in the soil is way more effective and efficient than storing water in reservoirs, which can lose huge amounts of water through evaporation. Storing water in the soil is also a lot more inexpensive than building more dams. So those are some considerations. So one of the main drivers of soil function and good soil function is organic matter. And we've come to realize this over the last 20, 30 years. Some soil gurus, I guess you'd call them, realized that back in the 30s and 40s, but those were very exceptional individuals. But as I said before, the lack of organic matter is one of the reasons why our agricultural soils are not functioning as well as they might, and we need to get them in better shape in order to better withstand some of the stresses we're going to be facing. Now, if you look at Australia right now, is literally burning up. Size of the burn area is about the size of West Virginia, I believe. If you look at the fires that California has suffered in the last few years, last year's record rainfalls in California, as well as that, and those record rainfalls followed very closely on several years of pretty droughty weather. So we're literally, I think we're going into uncharted territory here weather-wise, and if we're up to snuff, then I think our crop production, our food production, and our yield are going to suffer. So there we go. Rodale did some interesting studies, long-term studies, and the focus with Rodale is on organically managed soils, but there's a lot of good conventional growers that are extremely exceptional soil stewards. But what we're talking about here is well-managed soils, and well-managed soils can better withstand and yield during a moderate drought year than conventionally managed soils. And it's pretty interesting to see the side-by-side comparisons. It's the same soil, just managed differently. And on the organic side, or the well-managed soil side, it's not only that the soils have the ability to absorb and store more water just because they have more organic matter, but there's more biology in the soils which aid the plant's roots in accessing a larger volume for water and nutrients. So it's kind of a double positive, soils can absorb and store more water, but then they have more biology through times of stress. Sorry, these slides are moving slower than I thought. Okay, sorry for the hold up there. There's some basic principles that are based on regular additions of organic matter, just lessons from nature. Like why do the Great Plains, why do forest soils not need any fertilizer? Well, they're recycling a lot of organic matter. So regular additions of organic matter in diverse kinds of sources. I think soil at all time. A lot of folks don't realize that plants exude up to 30% or more of all their photosynthase. They exude those out from their roots, and that supports a very complex and diverse soil ecology that we're just now and protect the soil surface, living plants or mulch, having cover crops, mulch, irrigation water, sprinkler irrigation water, you have these little water drops that are essentially water bombs, and they can disaggregate the soil particles quite easily. And once you have that, you're not going to be absorbing and storing water very well at all. And I'll talk about that in more detail in a little bit. But having a protected soil surface, either through living plants or mulch, it also insulates the soil from extremes of temperature and sunlight. Bare sunlight, whether you're in California or Texas or Florida or anywhere, the soil microbiology doesn't really like extremes of temperature. And so you just want to using them eventually degrades into some organic matter that helps the soil as well. And keeping soil disturbance to a minimum. Physical tillage, physical disturbance meaning tillage, that has a negative effect on the organic matter, on a lot of the soil ecology. I mean, if you're a worm and you see a tillage implement coming down your way, it's like having an earthquake and a tornado at the same time, I guess, as well. And that includes pesticides, fertilizers. the organic matter in our soils, it's decreased and decreased by tillage because that kind of exposes, brings in more oxygen, so the carbon can be oxidized. But over the years in there really is literally like adding gasoline to the fire, because it gives the bacteria a lot more fuel to expend on eating up the organic matter, what little organic matter is left. So it's kind of a double negative whammy. So just keep the disturbance, chemical or physical, to a minimum, and including animals if possible, because animals can add a lot of biology through their manure, through their urine, and also, if well managed, through their hoof action, you know, trampling plants, trampling thatch and things like that. So what's the payoff? For adding organic matter? Well, it's better infiltration of rainwater and irrigation water, for one. There's a study that was done a couple decades ago by Huck, that's Huyck, Huck et al., 2003, in a sustainable agricultural farming systems research here in Davis, California, that showed that cover cropped ground increased summer infiltration, that's irrigation water. It doubled summer runoff by a factor of 10. And so imagine in the recent flood year, this last year, if you could decrease the runoff that's going down into the rivers, instead it's going down into the root zone, into the water table. That's a win for everybody. You have increased and improved nutrient cycling, decreased soil erosion from wind and rain because of the better particles, as well as protected soil surface, and also the organic matter resists as well. So if you have a heavy clay soil, the more organic matter you put in there, the better you can resist compaction, which is a problem not just for clay, but also for other kinds of soils. And then I've talked to several farmers, walnut and almond farmers, that have used cover crops to dramatically reduce their nematode problems, particularly in sandy soils. So there's a lot of payoff for adding organic matter to your soils. And then Steve was talking about, you know, the typical soil storage ability of water capacity of various soils. Really, the only way you can increase that water holding capacity in the soils is to add organic matter. And this is simple, you know, for every 1% increase in organic matter, particularly in sandy soils, you can add another 25,000 gallons per acre of water holding capacity. Sounds like a lot. Spread over an acre, it isn't that much, but sometimes it can make a difference between having a good yield or a bad yield, or it gives you a little bit of leeway if your pump breaks, or if your irrigation system breaks down for some reason, or if for some reason your local irrigation district doesn't send water your way for what reason. And so, and there's what's the cost of ignoring soil? What is the cost? Okay. Now here's a couple pictures. There's rainwater or irrigation water. The picture on the right is a picture I want orchard floor. This orchardist maintains pretty clean conditions, nothing growing in the alleys. And this is after, you know, a few days after rain. There's been the soil has been disaggregated, and the clay particles have gone to the surface, and it seals the soil. It literally seals the soil. So you have a condition that is illustrated on the left side. You have ponding in these orchards, and I've seen this time and time again over the years. These orchards pond, and that water is, some of it will slowly infiltrate into the water table and into the root zone, but a lot of it will evaporate off. A lot of it will run off and not make it back into the water table where we really need it and want it. And in addition, that water is carrying off fine clay particles, oftentimes that have phosphorus adsorbed onto the surface. So you're losing nutrients. You're literally polluting some of the downstream waters, whether it's your neighbor's farm or some river or pond or lake. And so it's kind of a lose-lose-lose situation. You have ever decreasing water storage capacity in the soil. You have soil erosion from wind and rain. And then you end up having conditions in the root zone, because the picture on the right illustrates the sealing, and it doesn't allow water infiltration, but it doesn't allow air infiltration. And so you have anaerobic conditions building up in the soil root zone, and that is, those are good disease-causing conditions. So you don't want to have that. So the reason I put this up, sand clay particles, these particles, all soils have some proportion of sand, silt, and clay particles. These particles, for a highly functioning soil, these particles need to be aggregated together. When they fall apart, what happens when they fall apart? There's no infiltration. You get those seals, the clay seals the surface of the soil. And the aggregation only happens in biologically active soils, and that's due to some of these soil glues, such as glomalins. We only discovered glomalins in the mid-1990s. That's a soil glue from fungi. Bacteria also secrete polysaccharides, which act like glues, and these aggregate the sand, silt, and clay soil particles. And that's a good thing. See in the next slide. Okay, I want to thank David Granatstein for this slide. I've used this in many presentations, but so he took a couple root balls from adjacent farms, same soil type, but the root ball on the left that has a lot of roots showing, that root ball was taken from what I call a heavily conventional farm. Lots of chemical fertilizers, lots of pesticides, corn, no cover crops, and the use of big equipment. The root ball on the right was taken from a conventional farm, but they used a good crop rotation of 3 or 4 different crops. They used cover crops. They used manure as a main fertilizer, and they had lighter, and they were also lighter on chemical applications. And so what David did, he just applied a garden hose to each of these root balls. The one on the left, the soil disappeared after about 30 seconds because there was nothing holding the soil together. There's no biology holding that soil together to keep that around the roots. And if you extrapolate that out to a landscape scale, that gets kind of scary. The one on the right, he kept that garden hose on there for a few minutes, and that's the result. It didn't wash away because there's biology keeping that soil active and keeping it together. Okay. I apologize for the slowness of these slides there. There we go. Okay. Even though the soil maintains its integrity around the roots, the aggregates allow better infiltration of the water. And so you can see on the right here, that's kind of a diagram that illustrates that walnut orchard floor. The clay particles form a seal, and then the rest of the water runs off. It doesn't go into the root zone. It doesn't go into the water table ultimately. And so what happens at the surface doesn't stay on the surface, but if you invest in your soils, if you start thinking about managing them as an ecology, then you can start developing your soil structure, you'll have better infiltration, and lots of positive things happen. So again, where in nature do you see vast stretches of bare ground for months at a time? That's I think this is, there may be good agronomic reasons for that, but you're kind of starving the soil. Particularly in California, you see this a lot in over winter. There's a lot of bare soil. It's not cover cropped, and you're exposing that soil to. But there's a lot of soils, a lot of cropping ground, annual cropping ground is now being converted to orchards, almonds, walnuts, pecans, and pistachios everywhere in California. And so there's a lot of conservation opportunities, particularly in the orchard sector because for almonds and walnuts especially, there are issues associated with harvesting the walnuts, and almonds are shaken, and then the nuts fall on the ground and they're windrowed and then they're swept up. But for the first few years of these new orchards, there's no production. And so not put in a cover crop and help that soil, help maintain your soil quality and help the tree and the orchard system at the same time. And I'm going to be focusing on orchards because there's so much orchard production in California. But a lot of these techniques or ideas or approaches are useful in annual cropping systems as well. Not so much chipping prunings, but this is one way to add carbon back into the soil, or use it, keep it as a mulch. It protects the soil, and I still see, this last weekend, I saw a lot of folks doing burn piles and burning prunings, and I consider that, shoot, it's too bad they're not chipping in and putting them in the orchard floor, because they grew the carbon, and you don't want to just burn off the carbon that you grew. And cover crops also are, especially in new orchards, orchards, and you can grow I'm sorry. There we go. You can grow a cash crop. You can grow wheat hay or some other crop. Sorry about that. There we go. So new orchards, cover crops, very beneficial. Certainly there are considerations for orchard floor management, needing to have clean floors for harvest, but especially for almond growers, I think that's something you want to consider. And there's a growing number of almond growers that benefit from this. They have reduced cracking in the high clay soils. They have better infiltration, even reduced pollination costs, and sometimes reduced nematode counts. Compost is another form of organic matter, and all of these are not incompatible. You can use compost, you can use cover crops, chip your prunings. They're all diverse sources of organic matter, and they'll all feed kind of a different set of microbes. So compost is another form, and CDFA has a healthy soils program that will provide up to $50 a ton of compost, up to 6 to 8 tons per acre. So that's a pretty good deal. And NCAT has been signed up as a technical assistance provider on these things. So if you're interested, give us a call. What I'm talking about is investing in your soils, meaning organic matter in your soils in whatever way you can, crop residues, compost, cover crops, but just getting more organic matter into your soils. It will help sandy soils retain more water. It will help sandy soils retain more nutrients, and sandy soils are particularly poor at both of those. And it'll help clay soils too. Putting cover crops in clay soils will help them absorb water. You won't get as much standing water in heavy soils. So a lot of positives. Cover crops do require management, and there's much of an art as it is a science to cover crop production, but there are these different approaches and different opportunities to invest in your soil to kind of bring it back and make it a lot more functioning. NRCS has EQIP, the Environmental Quality Incentive Program, IDFA's Healthy Soils Program. So there are financial cost shares that are available to growers across the country as well as in California. ATRA, NCAT manages the ATRA project. ATRA has a lot of information on soil management, compost, the soil resource, etc. Just ATTRA. There are some other sources. The Web Soil Survey, as Steve mentioned, SARE has a very good Building Soils for Better Crop. It's a great primer if you're just learning about soils. Cornell has a soil health training manual. Good farmers that are knowledgeable about soils are probably your best resource, actually. And NRCS has a pretty good soil biology primer and a few other resources. The biology of soil compaction, I think compaction is often overlooked as a problem in soils, but even animals can compact soil. So if you have, even chickens can do soil compaction. So keep that in mind. Organic Center as assessing soil quality in organic agriculture. But well-managed soils. I don't want to point the finger at organic agriculture, the end-all and be-all of soil management. ATRA publications. Sorry, I went too far. So that's it. I apologize for the kind of delay on the slide progression. That.
Great, thank you, Rex. That was a really great presentation, and
connection is maybe not up to snuff.
So yeah, no, Rex, that was really great, and thanks for presenting even though the slides were going a little slow for you. So if you have questions for Rex, please write in, and we'll start with questions just for Rex, and then we'll open it up to both Rex and Steve. And One question we have is that you talked some about orchard management and cover crops. What do you recommend for vegetable crops?
I would say it depends on what your goals for the cover crop are. You know, is your soil low in organic matter? You might want to plant some kind of small grain or something that would give you biomass. You know, I've helped a farmer transition some ground from conventional to organic production using just primarily just small grains, and that worked quite well. But it depends on your goal on the crop. If you're low in nitrogen, if you're going to be planting some or something that's a heavy nitrogen feeder, you might want to put in a cover crop of exclusively legumes like vetch or bell beans or some a mix of cover crops gives you what I call germination insurance. Even a mix of legumes, you know, like if bell beans don't do well in your type of soil, or maybe the weather is just not suitable for bell beans that particular spring or whenever you planted it, maybe the vetch will do better, or maybe the Austrian pea, or maybe you're using some other legume, clover or something. But a mix gives you some germination experience or insurance that I think is valuable.
Great, thanks. And then someone else is also wondering, the growers that you work with that have animals incorporated into their operations, how are they co-managing the animals with food safety?
Yeah, very good question. And you know, the food safety rule requires that any animals, if you're growing, say, vegetable crops that come in contact with the ground, you need to get them off 120 days before harvest of whatever vegetable or, you know, crop you're doing. For tree crops, it's 90 days, but I suspect for almonds and walnuts, because they're shaken and they land on the ground, it'd be 120 days as well. And I've seen, you just gotta know your animals. I've seen sheep being used to grade grass cover in walnut orchards. You just got to get them off in time, and know your animal too, because you don't want your sheep, you know, if you leave them on too long, they'll start kind of nibbling at the bark of the walnut trees, or, you know, you have to know your animals, the capabilities, and you have to have a system of moving them around and making sure that your ground's free of the manure by the time you harvest that crop. So the food safety question is a good one. And if you have some, if you're concerned about that, you can maybe do a bacterial test on your soils, you know, for salmonella or, you know, whatever pathogen you're looking at.
Great, thank you. And also just to add to that, Wild Farm Alliance has a lot of good resources kind of on managing food safety and conservation. And the Community Alliance with Family Farmers also has a lot of good food safety information out there as well. So, and we can send out some links to those resources. We had another question come in that is asking, what are your thoughts or suggestions for producing enough of your own organic matter on the farm other than animal manure? How do we produce more organic matter without extracting it from elsewhere?
I would say if you're not bringing in organic matter from outside, you know, like there's on-farm composting that can be done, but that brings in organic matter from the outside. Just growing cover crops, you know, during the winter, depending on where you're at in California or where you're at in the country, you know, in California, winter is our wet season, and most places don't freeze, and so if you plant, say, a veg cover in October, November, the soil's warm enough, it'll germinate, and then kind of real colder, rainier months, and then it'll take off again. But you can grow biomass using cover crops, but also, so I'm married into a farm family, and my brother-in-law farms organic ground, several hundred acres, and he grows corn, but he just harvests the cob and he leaves all in the field, and that's a huge amount of biomass. It's a lot of carbon, but his soils, you know, he's been doing this for opportunities to leave organic matter. You know, if you're growing a small grain, you could harvest the head and just maybe not harvest the straw for straw bales, just leave that in the ground, overwintering mulch, something like that. Just look for opportunities to leave crop residue in the field.
Great, thank you. And then one more question is, if someone was interested in working with NRCS or taking advantage of these California Healthy Soils programs, what's the best way, kind of what's the process that you would go through? How do you contact the person? Is there an application? If you could talk a little bit about that.
Yes. If you're looking for Natural Resources Conservation Service, generally has a county office in most counties in California, and actually across the country. Areas might have to go to the adjacent county, but talk to your local soil conservationist or your local district conservationist. You can go on the website on internet for NRCS field office locations, and it'll generate out of the US, and you can click on your state, and then it'll eventually you can click on your county and find the contact information, NRCS office. If you're in California, you can want to access or you can give NCAT or there's other folks like CAF, and there are going to be a bunch of technical assistance providers for the Healthy Soils program. The Healthy Soils program will be putting out their requests for grant applications, meaning, you know, their cost share application. It's in January or early February, and then they'll just go to the CDFA Healthy Soils program. They will have a list of technical assistance providers. Hopefully their online application will be simpler than the previous couple of iterations. We've helped folks apply. We've applied on behalf of some folks that are Spanish speakers. Go to that website, the CDFA Healthy Soils Program website, and you'll be able to find a technical assistance provider that's operating in your area, or give NCAT a call, because we're going to be one of those.
Great, thank you very much. So I think we're gonna wrap things up, but thank you again, Steve and Rex, for your presentations and taking some time to walk us through, the benefits of both managing your soil and irrigation systems well to make good use of water and the best use of your soil. So thank you for participating. And we'll just have a few wrap-up slides. CCOF has some webinars coming up this winter. We're having a organic seedling production webinar at the end of January, and then a disaster preparedness webinar for livestock operations in February. And then at the end of February, there's the annual CCOF meeting in Sacramento. It's a good way to connect with people in person. So thank you again for joining us today, and please fill out your evaluation form. When we close out of the webinar, it'll pop up, and we always love getting feedback and ideas on what we can do future trainings on, as well as how we can improve our offerings. And just to note that that survey is not anonymous. The way GoToWebinar does their surveys is it's attached to your name, but we appreciate all types of feedback, even on what we can improve. So thank you again, everybody, and have a good afternoon.